All right, looks good. Seems like we are online. So a warm welcome and thank you very much for your interest here with the webinar of K2 Systems. Today we will introduce our new flat roof system to you. My name is Marco. I'm from Business Development.
My name is Ronnie. Hello from my side also. I'm from Technical Sales Department, and later I will show you how to calculate a project with our new flat roof system, Dome V.
Exactly. So let's have a look into our agenda for this 1 hour. So we will have a look at some slides. So I will go a little bit into the theory of our new flat roof system, which is the S-Dome V and the D-Dome V. We will have a look at the advantages and the system structure, and then we will have a look at the hand samples, the real parts that are lying next to me here on the table. And then, as Ronnie mentioned, he will show you how to plan a system in our planning software based on. And then, of course, we will have, in the end, lots of time to answer your questions. You can ask questions at any time. You can raise your hand in the program or type into the chat window. All right. So now you should see the first slide of the little presentation. You can see here on the right-hand side is the single-sided elevation, which is the S-Dome V, and on the left-hand side you can see the D-Dome V. D stands for double, so double inclination, and also you can see here on the left-hand side the V shape of the system structure. This is how the name was created, D-Dome V and S-Dome V. Usually the S-Dome is installed towards the south side, and the D-Dome V is usually installed towards east-west. In some applications, it might be also interesting to install south-north, also possible. So we have a look at some features of these systems. The D-Dome V and the S-Dome V both have a completely modified geometry. It's the 5th generation now of our flat roof system, and we modified the geometry completely. We scaled down the weight as well as the volume. This is, of course, a huge advantage for the transport volume, as well as the installation gets much more handy with smaller parts. We have one short mounting rail with an integrated ballast tray. This is completely new. You probably know our speed rail. That is the base rail for our existing dome systems. Now we modified it and included a ballast tray. So the stones can be placed directly into the rail. In some cases where you need higher ballast loads, there is optional parts where you can place bigger stones. Then one huge advantage and one main feature of this new system is the flexible EPDM support pad, which compensates tolerances and movements. So basically all the forces, probably wind force, that are attacking the PV modules, this force will not be implemented into the roof itself. So this flexible EPDM pad is basically compensating all movements that are happening on the PV panel. At the same time, it has also a better friction coefficient. So with this better friction coefficient, we are able to reduce the ballast for a system and bring down the cost. I mentioned before lower transport volume to reduce logistics costs. This was also a saving in material. So we can talk about a cost reduction compared to the last generation of the system of at least 5%, which is quite significant because we are facing right now raising material prices. The aluminum price went up, and instead of raising the prices of our system, we are able to reduce it. And of course, as usual, aerodynamically optimized based on wind tunnel tests, one of our main features. So let's go to the next page where we can see the different components. As mentioned before, we have the rail as a basic element, and in black you can see the EPDM pad, which has this honeycomb structure to absorb the movements. Same parts almost for the S-dome V, and of course we have one additional part here, which is the windshield. Then we also can show first references. This is the S-dome V, so facing south, a 200 kilowatt system installed in Hanover, Germany. And yeah, the feedback of the installers was pretty good. Some points have to be modified, but this is what we are working on right now. So it is very important for us to always get the feedback from the market, from our customers and installers, to, of course, at all time optimize our products. Same for the D-Dome V. We have here a 700 kilowatt system installed in Oldenburg, Germany, and despite the rainy weather, I think it was a very enjoyable installation. All right, now we go over and show you the real parts. Therefore, hang on a second. We need to switch the camera. All right, perfect. I think you are having a look at our table right now. Should work. Now, let's start with the D-Dome V. This is the S-Dome. We will have a look later. Now we look at the D-Dome, and here you can see again, this is the shape of the V. So D-Dome for double inclination and V for this shape here. We disassemble it for a minute just to show you how to do it. So now this is the base rail. As mentioned before, you have the ballast trays included, and here you can see the honeycomb structure of this EPDM protection mat. With this is the original size. This one is just a small part to show how it works. You can see here this side is facing the roof and this side is facing our whole structure, and you can see how the movement here can be compensated so that no forces are going into the roof.
Yeah, for fixing the inclination parts or the elevation parts, you just take our MK2 nut, you place it here in the middle, you turn it around, and then you can put the part on top and fix it with a common screw. It's very easy compared to the earlier system. You only need one screw to fix the upper part, and the best thing is that you don't need any screw for the lower part, but we will mention this in a second. These two parts are very safe to install because you don't have the option to install it in the wrong way. It's not possible to insert it like this.
Poka-yoke system, right?
Yeah, the Poka-yoke system, yeah, which says that things cannot be installed in the wrong way, but only in the right way, like this.
Exactly, and as Ronnie mentioned before, for the lower part here, we don't need any screw at all. So this part here has no screw function, but only a turn-in function. So you go like this, put it in, and then you're flexible here, depending on your module size. So the module is lying from here to here. And when you fix later on the screw here, then this part will be pressed down and will be stable in position. But you don't need any screw here. So the only screw in the whole system is basically this one. Everything else, all the other connections are slided in, turned in, or clicked in.
We have a model prepared here. These two tubes simulate your module frame, and here you see one of our middle clamps. And now, as long as the clamp is not fixed yet, you can move the part, but as soon as I fix the screw and so fix the modules, this is stable without any additional screw.
Yeah, so basically the module clamp has also the function to stabilize the system.
As a clamp, we now use our mini clamps. You already might know these mini clamps from our mini rail system. These clamps are good for module frames between 30 and 50 millimeters, so you won't have the problem anymore that you have the wrong clamps on your construction site.
Yeah, exactly. So this was the D-dome V with double inclination. Now this one is the single elevation, the S-dome V. As mentioned, almost the same parts, just with this additional geometry here to fix the windshield on the back.
I can show you here. These are the two channels for fixation of the windshield.
Exactly.
Okay, let's go on. Okay, so here we are already on the start page of phase 1. I am already logged in, and I suppose you all have an account yet. If not, this will be the next task for you. Create a phase 1 account. To log in, I think this is very easy, and you all know how to log in once you have your account, so I will go over this point. So here on the first page, I have 3 possibilities. I can open an existing project within my account. I can have a look on some help functions. Feel free to go through all these points. Might be very interesting and helpful for you. So what we want to do now is we create a new project. So I push this button here and I get informed that unsafe data for the current project will be lost. But as far as I don't have a current project, that's okay. So we wait a little, and then now I have the map of Germany and my pin is in the middle of Germany. So the first thing is I can type in the address of my project here, and I take the address here in Renningen, where we are with K2. And for now, I won't type in a number, but only the street. So this is K2 Systems, as you can see here. This is the Industriestraße, and here is my pin now at the moment. But I have the possibility to search for my building where I want to plan and calculate, and this is my building, and I can move this pin here from here to there just by double clicking on this building. And as soon as I do this, my address here
changes. So this is a good way to set your address for the project. By the way, if you don't find your building yet, it's no problem to draw a roof just on a field or into a lake or on a street. Doesn't really matter, because what we do is just calculating the statics and the wind and snow load and calculating the material you need. So this doesn't differ if you build your roof here or there. So let's go on and give our project a name. I call my project test. We have the Euro code here, so we don't have to alter this. The author, that's me. And you can type in the name of your customer and the contact person of your customer. I won't do that now, but go on to the next page, roof. And here I will add a new roof by using this plus sign. And now I have different possibilities: monopitch roof, gable roof, and for today we want to draw a flat roof. For flat roofs we have two possibilities: the polygon roof or the rectangular roof. Now I want to draw a rectangular roof, and of course a rectangular roof doesn't have a surface of tiles or trapezoidal metal sheet or standing seam or corrugated metal or fiber cement, but it has membrane or bitumen or gravel. So this is the only possibility here. I cannot click here. If I do, nothing happens. So I go on and add the roof. I can scroll in a little bit by using the wheel of my mouse or by using these two buttons here. And then I go to the edge of the roof, to the corner of the roof. I click with my mouse, then I move my mouse. I click again, and I move the mouse again. And I click for a third time. And now here we have the roof. You also see the measurements of the two edges here, 22.93 and 21.16. Maybe I have measured the roof before, so I can alter the size afterwards just by using the mouse like this. Or I also have another possibility, but only in the 2D view. So I go into the 2D view, and then I can alter the measurements of the roof by just typing the actual values here. And I can say the alternation has to take place on this side of the roof, or on the other side of the roof, or on both sides. So I want to alter the size of the roof on that side, so I click the right arrow. I can also do it for this roof edge. And I can go back now to the map view or stay in the 2D view. I go back to the map view. I can alter the building height and the roof pitch. So let's say it's 9 meters high and it's 2 degrees pitched. I can type in the parapet wall height and the friction coefficient. For our new mat V, we can take a friction coefficient of 0.5 as long as we don't know the actual friction coefficient. But before the installation of the system, you absolutely should measure the friction coefficient on your roof by using the friction coefficient measurement device. This is very important because the friction coefficient, of course, influences the ballast in the end. So the smaller the friction coefficient is, the more ballast you will need. So in the end, it could be if you have a friction coefficient which is too high, let's say 1, and in the end it turns out that it's only 0.6, then you have too little ballast, which is not good for stormy weather. So now we see we have an obstruction here in the middle of the roof. We can draw an obstruction also by using one of the signs in this area. We can draw polygon obstructions, rectangular obstructions, or just lines. Let's start with a rectangular obstruction. I zoom in a little bit by using my mouse wheel, and first I draw the first edge of my obstruction. The first line always is rectangular, orthogonally to the roof edges or parallel. Yeah, it jumps from one roof edge parallelity to the other. If you don't want this, you can push the Shift key on your keyboard, and then you have the possibility to draw your first obstruction edge as ever, as you want. Yeah. If I take my finger off the Shift key, it's parallel again. I can alter the size again with my mouse. And I can also go to the 2D view and alter the size of the obstruction just as we did it before. I can also give my obstruction a height. Let's say this is 0.5 meter, and I can give it an edge distance, let's say 40 centimeters. Now I see the area where no modules and no under construction will be afterwards. I can show a shading from my obstruction, so later on you can use this shading when you want to decide if you want to place modules here or not. We also have another possibility. I want to show that if you click this little sign up here, then distances of your obstruction are shown, the distances from the edge. So here we have 10 meter and 11, and of course I also can alter this value, let's say 10 meter and 10, but not 10 meter and 11, and here maybe 6.2 meters. So let's switch to the map view again. This is how it looks. And now we want to proceed and draw a module field. So we go to design. You have the possibility to choose between different module manufacturers, or you also have the possibility to say, yeah, I want to define the measurements of my module by myself by typing in the values of your module here. So let's go on and just draw a module field. We want to start with the D-Dome V system. This is our new flat roof system, and as soon as I choose the system, the two choices, module orientation landscape and installation type elevated, are chosen by default. So now I only have to decide if I want to have modules on the complete roof or only a smaller module field. But even if I want to place modules on the whole roof, I choose module field because then I am more flexible afterwards. I really recommend that you always choose module field. I will do that now and show you that you also can place your module field all over the roof. I myself, I always start, I draw the module field just on the yellow line. The yellow line is the line where in between these lines you can place modules. You cannot place modules outside of the line. I can show you that in the 2D view. So if I enlarge my my module field like this, or even over the edges of the roof, you see nothing happens because our wind channel tests say that you have to have a edge distance for your modules of at least 60 centimeters for the two dome V systems. This value is also preset here, 0.6 meters. You cannot go under this value, like 0.4. Now you see it always goes back to 0.6. But of course you can type in a larger value, like 1 meter, and then your yellow line will be further inside of the roof. Let's just keep this value for now. You see here we have 11 modules in a row, and we have 10 modules 11 modules in a column and 10 modules in a row. So in here you can see we have a thermal cut. This is after 1, 2, 3, 4, 5, 6, 7, 8, 9 modules. You see here we have the thermal cut after 9 modules. You can alter this value, of course. Again, you cannot type in a larger value because after 9 modules here you have to have a thermal gap. But of course I can type in a smaller value, which I recommend, because here we have 2 module blocks which are not equal. So we have different ballast values also for the upper block and the lower block. Let's just have a look on these ballast values and come later to this page and see what else we can alter. I proceed and go to loads, and here you can see that we have the loads for our project automatically calculated because this project is in Germany, and for Germany we have a national attachment as we have for many other countries. And yeah, after some time we will add national attachment of more and more other countries too. But here, as I know that my project is in the Benzstraße 43 in Renningen, I don't have to find out the wind load and snow load because these values are calculated automatically. The only thing I can do here, or I should do, is check the terrain category. Here we see the default value is 2/3. So hedges, farms, scattered houses or tree, agricultural area / surrounding suburbs, industrial or commercial areas, woodlands. So in this case, I think we have a look again to the area. Yeah, I think we can leave it like this because it's an industrial area, but here we also have open fields nearby. So let's just leave it 2/3. Here you see the the peak velocity pressure and the snow load on the ground and on the roof. Let's go on and have a look at the results. Here again we see our thermal cut and we see all the ballast values. Now we see we have quite different values. Here we have 18 kilograms, 48 kilograms, 29 kilograms, 0 kilograms, 30.5 kilograms. So let's have a look if we can give the ballast values on our roof a more homogenic picture. Let's go back to design and edit our thermal gaps. We have two possibilities. I switch to the 2D view because I think we can see a little better then. So we have two possibilities. We can say, yeah, I want a thermal gap not after 9 modules here, but maybe after 5 or 6, because it's more in the middle. This would be one possibility. I type in 6, and then the thermal gap will go down here automatically. It's still calculating. You can always see if the software is still calculating, then you would have to wait. But maybe I still want to have the thermal gap not here, but maybe here. So I also can click the button Edit Thermal Gaps, and now I can click on this gap here, or between these two rows, and now I see, okay, the yellow color means that I can edit this gap. I can say I want to have a thermal gap here, yes, and now I have the thermal gap, and I can remove this one. But we have an interesting thing here now. I have a message and a red module field here. You have planned a single module array. However, the minimum array size is 2 connected modules. I mean, this is 2 modules, but what we mean here is actually we need 4 modules. So 2 double module fields. In this direction or in this direction. So obviously we don't have a connection between this double module field and this one, or between these two, and also we don't have a connection between these. Otherwise this message would not be shown. So let's, as a first step, remove this thermal gap, which is now a thick yellow line, and if I remove this little hook here, then the line gets thinner and I don't have a thermal gap here anymore, and I don't have my message. So now these double module fields are connected. We can also see that if we edit thermal gaps not horizontally but now vertically, and as you can see we have a thermal gap here, which is shown also by this value, thermal gap every 7 modules, 1, 2, 3, 4, 5, 6. It's only 6. Yeah, that's because my first module, which is counted, is not here actually. That's because I altered this yellow line before. So I now have 2 possibilities. I can move my module field, or I can make it a little smaller by using my mouse, or I can go back to the default value, to the minimum edge distance value of 0.6, and then my modules here should reappear. So let's have another look. Thermal gap after 7 modules, 1, 2, 3, 4, 5, 6, 7. Of course, I can optimize the ballast values again by moving this thermal gap into the middle. So I first set my new thermal gap and then I delete my other thermal gap. I cannot proceed now because I first have to finish the thermal gap editing modus. So let's have another look to the results and to the ballast values. And now you can see everything is more homogenic. The very high ballast values are not there anymore. It's much lower now. It's only the highest ballast is now 18.5 kilograms. So this looks really good. So let's go back to design and switch to the 2D view again. As I mentioned before, we also now can decide if we want to have modules in the shaded area. I think on the 21st of December, the shade we have here is maybe not so important, but still I want to show you how to delete single modules. You can do this by clicking this little rubber sign here, so we can just erase the modules around our obstruction which are influenced by the shading. So let's do it like this, and again I have to finish the erasing mode, and then let's again proceed to the results. But before, I want to show you that you have module field informations here. Now you can see we have 168 modules all in all. Let's go to results. So this is how it looks now. And here on the left side, you see the ballast capacity, which is 30 kilograms for the dome, or let's better say for the rail. As we showed before, you can place ballast stones on the rail directly without having any additional parts. You can also modify this ballast capacity if you use the same stones for your projects again and again. Maybe you already know that you can place a specific amount of stones on the rail, and maybe your stones are a little different. And you know, okay, all the stones I can put onto the rail are not 30 but only 28 kilograms, so you can modify this value. And then the system knows that if you have more than 28 kilograms, then it will add you speed porter for higher ballast into your bill of materials. You can of course do the same for the speed porter and the porter value. As a building protection mat, earlier we had two possibilities here, but the EPDM mat is good for membrane roofs and bitumen, and also for gravel. So only one mat for all surfaces. Let's go to the next page, summary. We see we have one roof, and this is our bill of materials for this roof. You could edit your bill of materials by clicking this button and then say, okay, I have plenty of mat V in my warehouse, so I won't need them because I bring them myself. You can apply it then and go on. Don't forget to save from time to time. I have the possibility now to download my base on file by using this button. So you have the file locally on your computer, and you can, for example, send it by email to your colleagues, to your customers, or to K2 Systems if you want us to check your project, for example. Okay, we have a good question. The question is how to change module orientation. I will show you that now, but first I give you the information that my edited bill of materials will be reset as soon as I do some changes in the project, which I will do. So I go back to design, and now it could happen maybe, well, let's add a new roof. Sometimes we add a new flat roof, rectangular, flat. Sometimes we have roofs which are maybe like this. And then maybe somebody wants the modules to be faced in this direction or in this direction. And we can alter this. So let's plan a S-dome system now. We go to module, and before I defined user-defined modules, and now I can use the same modules for the new roof by clicking this button. So now I have the same module measurements as before. I go to module, arrays, I add a new module field. This time I use S-dome. If I go on add, now I see the green line, and this shows me that my modules will be faced to southeast now, yeah, and I can alter the orientation only if I delete my module field. Yeah, I have to delete it by using this X button, and now I can modify the orientation by clicking the button M for manually, and then I choose my northern roof edge, and now this edge is green. So my modules now will be facing towards southwest. I take the S-dome V system again, add, and make my module field. Now they are facing southwest. So yeah, as I mentioned before, you can draw a roof also not on an actual existing roof, but on a free area, or even on another roof like this. Maybe this building doesn't exist anymore. It was torn down, and somebody's planning to build a new roof here, something like that, because the satellite pictures are not that actual always. So let's go on, switch to the 2D view. In the S-dome system, the row spacing is set automatically. The more north you are, the larger is your row spacing, and the closer you are next to the equator, the row spacing is smaller. So let's go on to loads, and again we have the loads calculated automatically. And when we go to results, now we see the ballast values for our second roof. Here the ballast capacity is a little different from the D-dome system. That's because the S-dome rails are a little shorter. Yeah, concerning the rails, I want to show you that you can see the rails here in blue, and a row always starts with a long rail and ends with a long rail, and depending on the size of the block, you have short rails or short and long rails, or only long rails in between the first and last. Here you see we have two short rails in between. If I go back and I click my module field, and now it's active, I can see that because of the dots in the edges. I move it to the very edge and I make it a little larger, and I have one row more, and now my my rail picture looks a little different. Well, I still have three short rails here in between. So let's have a look on roof 1. Here the rails are going from east to west. I zoom in a little. We have a long rail and a long rail, a long rail here and a long rail here in the middle, and then we have two short rails. No, one long rail and one short rails. It's a little blurry. So let's go on to summary. Now we see we have two roofs and we have one bill of material for both roofs. First the D-dome system, and then down here we have the materials for the S-dome system. You can not only download the file as I showed you before, but also generate our static report. You already know from our other systems. It's a PDF file. Now it's downloaded. I can open it. And yes, here we have first our project data. Then we have the module design and design and measurements for all the module fields, ballast, and some calculation, loads, static report, and here the information that the system has been successfully calculated. Bill of materials for roof 1, then comes the same for roof 2, bill of materials for roof 2, and in the end bill of materials for both roofs. You can also download the bill of material as an Excel file, which is here, and you have a third possibility or a fourth possibility to download the ballast plan as an Excel file too. So here you also have the possibility to make further plannings, like maybe your string planning. You can draw lines here between the modules, for example. Or you can calculate the amount of stones or ballast you need, whatever. Okay, so I think we made it until here. We have a question, can we see total ballast in kilograms? Yeah, we have two possibilities to see the total ballast in kilograms. First possibility is here in the PDF file. Where was it? Oh, I went too far. Yes, here. Now here we have the results of roof 2. We have only one block. Yeah, I better show it to you on roof 1. I think this makes more sense because on roof 1 we have several module fields, 4, and here you have the total ballast for module field 1, 2, 3, and 4, and here the total ballast for all your module fields. And yeah, by the way, this values show you the weight of the system all in all. That means ballast and mounting system and modules.
So you can check the load values of the roof.
Yes.
With this value, you can...
Exactly. You can compare which dead weight is allowed on your roof and if our system or your PV station is under or over this allowed value.
Yeah.
So we have many questions of one participant. To be honest, I really don't understand all these questions. So maybe it's better if you just give us a call later or describe your problem precisely in an email. I think this makes more sense.
Yeah, it seems like it is some specific questions about a specific project, but is there any other questions that we can answer right now about the new system, the dome that we presented, or also about how to calculate? All right, anyway, we will stay online for another couple of minutes, so you can still take your time and type in your questions. But I think for now, we can say take care, bye-bye, and thank you very much for your interest.
Yeah, thank you very much, and have fun using base on and have success in calculating your projects.